Hello, everyone, and welcome to our leak repair channel, where we bring engineering insight to the world of industrial leak repair. I'm Tim Gaida, a professional engineer at My Engineering Limited. Today's topic is how enclosures can damage piping with external pressure and how to avoid it. Let's walk through how this happens, why it matters, and what you can do to avoid creating a new failure while trying to fix an existing one. When an enclosure is installed using a void fill seal, a technician will typically inject sealant into the cavity using an injection pump. This pump forces the sealant under pressure, causing it to travel throughout the enclosure until it fills the entire void. While the injection pump is hooked up to one of the injectors, the other injection valves on the enclosure will remain open to act as vents while the sealant is being injected. That way, pressure doesn't build up, the sealant can displace air freely inside the enclosure, filling the enclosure without compressing the pipe. However, the moment the last injector is closed, that's when pressure can build. Technicians will usually pressurize the sealant at this point to ensure it fills every remaining void and compresses the sealant adequately. That's where external pressure is applied directly to the pipe wall. In most cases, this external pressure isn't an issue, but in applications where the pipe has general or local thinning, even moderate external pressure can introduce a new failure mechanism. This could lead to pipe collapse, bulging or deformation, or in the worst case scenario, a new rupture in the pipe shell. On the engineering side, there are a few things we do to minimize the chance of external pressure damage. We start by running a UG28 external pressure calculation to determine the maximum allowable external pressure the pipe can handle before it collapses. This value becomes our maximum injection pressure and is communicated clearly to the technicians in the field. In cases where the UG28 result is too conservative and not practical for real-world injection, we run an FEA on the pipe. This gives us a far more accurate simulation of how the pipe behaves under external pressure, especially when thinning or local defects are present. It is important to note that end users must provide accurate NDE reports on the pipe wall thickness, as this information is directly input into our calculations. The better the data, the more realistic and safer our recommended injection pressures will be. Now, even with the best engineering controls in place, field technicians still play a critical role. One of the things they should monitor is the volume of sealant being injected. Thanks to modern 3D scanning technology, we can estimate the void volume of the enclosure very accurately before the repair even starts. So if the technician notices more sealant is going in to the pipe than was calculated, it could mean that the pipe is deforming under pressure. That's a cue to stop the injection immediately and to reevaluate. To wrap this up, enclosures are meant to solve problems, but when improperly injected, they can create new ones. External pressure from sealant injection is real, and it must be managed with the right engineering, field practices, and collaboration from the end user. Thanks for joining me for today's discussion. If you'd like to learn more about topics like this, please subscribe to our channel or join our mailing list. We'll send you more great information as it's released. You'll find the mailing list link in the description below. Thanks for watching.